For centuries, people believed light was pure and white, and that object simply added color to it. Think about a red apple. The skin of that apple is absorbing every single color from the sunlight, every wavelength, except for red. It rejects the red wavelengths, bouncing them straight back into your eyes. The microscopic scales on the butterfly's wings are shaped like tiny Christmas trees. It's a dazzling trick of physics, engineering brilliant color out of pure geometry rather than chemistry. Water is a dense medium, and it acts like a massive filter for sunlight. Red light, with its low energy and long wavelength, is weak. It gets absorbed almost immediately by water molecules. By the time you dive just 30 feet down, the color red no longer exists. If you cut yourself, your blood would look black. Orange disappears next, then yellow. This filtering effect is exactly why the ocean is blue. Blue light, with its short, high-energy wavelengths, penetrates the deepest. It scatters and travels where other colors simply can't follow. In this midnight zone, the rules of color are completely rewritten by the inhabitants themselves. They create it through a chemical reaction involving a compound called luciferin and oxygen. They use this living light to hunt, to attract mates, and to scream for help in the absolute, crushing silence of the deep. When we look at images from the Hubble or James Webb Space Telescopes, we're greeted by a kaleidoscope of neon pinks, electric blues, and burning oranges. Are those colors real? Yes, they are. And they tell a violent, epic story. Consider the great nebula in Orion. It glows with a distinct pinkish-red hue. This color is the unmistakable fingerprint of hydrogen gas. When intense radiation from newborn stars blasts into these massive clouds of hydrogen, it excites their electrons. As those electrons calm back down, they release a photon of light at a very specific wavelength known as a alpha, which sits firmly in the red part of the spectrum. The universe is literally painting with hydrogen. Then you have reflection nebulae, like the ghostly blue mist surrounding the Pleiades star cluster. This isn't glowing gas. It's just cosmic dust, reflecting the light of those bright, nearby stars. It's the same reason our sky is blue. We call this redshift. If an object is rushing toward us, the light waves get compressed, becoming blue, or a phenomenon called blue. We discovered the Big Bang, not by seeing the edge of the universe, but by reading the color-coded messages sent to us from across billions of light. As we admire this magnificent chromatic rhapsody, we have to be humble, because the truth is, we are almost blind. We can't see the heat leaking from our homes in infrared, or the damaging UV rays from the sun that give us a sunburn. Even our vision is limited. We are trichromats, with 3 types of color-receptive cones in our eyes, for red, green, and blue. Compare that to the mantis shrimp, which has up to 16 types of cones. They can see forms of polarized light and colors we can't even begin to imagine. To a bird, which can see in ultraviolet, a simple flower might be covered in glowing patterns that act like secret runways, guiding it to nectar patterns completely hidden from our eyes. We are experiencing the universe through a tiny keyhole. The symphony we perceive is just a simplified melody taken from a much more complex, largely invisible orchestration. In the end, the study of light and color bridges the gap between the cold mathematics of physics and the warm, emotional experience of being alive. When you watch a beautiful sunset, you're not just seeing pretty colors. You are witnessing Rayleigh scattering. The sunlight is traveling through a much thicker slice of Earth's atmosphere, which strips away the blues. From the structural blue of a butterfly S-wing to the redshift of a galaxy retreating into the void. From the chlorophyll that feeds our planet to the bioluminescence that lights the abyss calories information. It is the universe telling us what it's made of, how hot it is, how fast it's moving, and how incredibly alive it is. And by learning to decipher the spectrum, we don't strip away the magic, we deepen it. We realize that the universe is far more vibrant, far more complex, and far more beautiful than our eyes alone could ever tell us. Thanks so much for watching. If you enjoyed this journey into the science of color, be sure to like this video and subscribe for more explorations into our amazing universe. See you next time.